Today is to get ready for the first test on chapters 1, 2, and 3. Somebody asked a question a few minutes ago, and I figured I'd just start with this. Number 29 in the assignment for chapter 3, among others, you probably noticed every once in a while you'll see this phrase, the standard normal distribution. And remember this notation, N. What does that mean? That means normal, and the first number in parentheses is the mean, and the second number in parentheses is the standard deviation. Well, the simplest possible normal distribution is the standard normal, where the mean is 0, and the standard deviation is 1. So you notice in our picture what that looks like? The mean is 0, and then each notch is just the simplest possible division you could think of. They go by 1. So it's kind of the neatest, the simplest normal distribution, and for that reason it's called the standard normal. So when, for example, you were doing problem 29 and they said to you, you've got a normal distribution. If I can find my way here. Yeah. So on 29 they said you've got a standard normal distribution. Notice the first thing I wrote up in the corner is mu is 0, sigma is 1. That only can be done when it's a standard normal. Okay, so anyway, I thought that was important enough that we spend a little time on that. So, I've got actually two things up. I got chapter 3 stuff, if you want to keep asking about that, and I've got a separate thing where we just think maybe about all 3 chapters. And I'm a little bit worried that while I want to keep going on chapter 3, I don't want to, I'm a little bit more worried about chapters 1 and 2 because a little bit of time has passed since we had those. And so I'm not, I mean, the concepts weren't hard, but let's not forget about chapters 1 and 2. By the way, if you look on my WLC, you'll notice I always have been listing the learning objectives for each chapter. Here I just gathered them together, and this is like a checklist. If there's one thing you should do as you study for this test, I would say, can you go through these, what do we have here? 4, 11, we have 18 things supposedly that I taught you how to do in those 3 chapters. Okay, and you could literally use it as a checklist. Do I really know how to do each of these? Of course, I probably can't ask you to do every one of those, but you know how it goes. Murphy is alive and well, and if you only study 17 of them, you can bet that I'll ask you about the 18th one on the test, right? And it's not because I have inside spies, it's just because of Murphy's laws. When I said Murphy, you guys have all heard of Murphy's laws, right? Okay. So anyway, it just seems to make sense to go through that. And if there's something in that list you can't quite remember how to do, that's a perfect guideline for what to review. And so it wouldn't hurt to work on everybody's got weak points. Work on your weak points, firm up your strong points. Come into the test as relaxed as possible on Wednesday, ready to go. You want to get a good night's sleep, all that kind of stuff. It's better. So, where do you want to go? I'd really like to go at your direction. You can ask questions on chapter 3 yet, but let's not forget about 1 and 2 also, okay? So this is pretty much, I'd like to respond to what you'd like. And you don't have to copy anything like this down because it's available on the My WLC page, but I just thought I'd remind you that that wouldn't be a bad way to go. On
Chapter 3. No,
chapter 3, on
number 3.
Number 3.
315.
Oh, number 15 on chapter 3. Okay? The answer is yes. Okay, let's see what we got here. And we don't have one like that, so we'll put one in here. Okay. 315. So this is 3.15. And there's a little bit of information up above this, isn't there? Like it tells us the mean. Oh, this is the Wechsler, this is an IQ test, basically. They tell us that the mean is 100, standard deviation is 15, is that right? Yep. So let's get that information down. Now, 315, about what percent of people have scores above 100? Now, I don't even have to look at a chart for that one, because isn't 100 the mean? So shouldn't there be 50%? Yeah. And so part A, they're just kind of a general knowledge question. What percent of people should be above that? Okay, part B. How about above 145? Well, now I have no choice but to pull out my standardization formula. And in this case, 145 is my x. I already know my mean. I already know my standard deviation. And what is that on top? 45 over 15, which is exactly 3. Okay, so now I have a z-score of 3. Now, here's another little caution. Notice it asks for above. Remember, the table gives you below. So let's look up a z-score of 3. And I see I get, what, 0.9987? Do you see that when you look up a z of 3? Okay, so I got to do and the answer would be 0.0013, which is in percent form 0.13%, or maybe I should even write it like this. A pretty puny amount. Let me write that up here now. An incredibly small number of people have IQs over 145. Okay, and I lost my place. What was next?
I know how to see, I just wasn't sure.
Okay. All right. $323? Sure. Well, I got it started here. Yeah, this is the one with the men and the women mixed together, right? Yeah. Heights of women are age 20 to 29 are normal following normal distribution, mean 64, standard deviation 2.7. Oh yeah, I got it up there under the women. And for the men, that's normal with a mean of 69.3 and a standard deviation of 2.8. What percent of young men are shorter than the mean height of women? Okay, what percent of men are shorter than the mean height of women? So in other words, they're saying, use for your score for men the mean height of women. Okay, so then the z-score would be 64 minus, and now this is back to men again, right? So I got to use 69.3, and I got to use the men's standard deviation. Okay, what do we get on top? Negative 5.3. And that's divided by 2.8. And let's quick check out what that comes out to. 5.3 divided by 2.8. Negative 1.89. So now I got a z-score. Now it's time to pull out the table. And by the way, what did they ask for, greater or less? Shorter. So we can use the table directly. Negative 1.89. 0.0294. So that would be 2.94%. Does that make sense? That would be a tiny number. What percent of men are smaller than the average height of women? It should be a small amount. That makes sense, doesn't it? It always pays to do a little bit of that too, just in case you got something reversed in your head. You look at your comment, you do a common sense check and you go, whoa, wait a minute. That doesn't, here it does. It seems right. Excuse me. Yes. 21 on the same on chapter 3. Okay. Uh, 21. NCAA. A partial qualifier, somebody who's eligible to practice and receive athletic scholarship but not compete in the games if their SAT score is at least 720. And then there's stuff on the previous page. Oh, 820 is when they become eligible. 720, between 720 and 820, they're kind of half eligible. They can practice, but they can't play. So what they're saying is, how many fit in this half eligible category? So what they're really saying is, we got to find the people between 720 and 820. Well, maybe I read it wrong. Oh no, you're right. They are asking for that. So why do we need the previous exercise?
Because it tells you the mean.
Oh, the mean. Yeah, you're right. Okay, so here it is. You're right. We got to do just a 720. So we take our 720, subtract the mean, divide by the standard deviation, and I came up with a negative 1.45 for my z-score. And I guess I haven't done the table yet, so let's do that. And we want the percent, so we got negative 1.45, 0.0735. So in percent form, that would be 7.3.
I got that too because I checked back and looked and it said it's supposed to be like 9. And that's why I was...
Oh, anybody see anything I have done wrong here? Interpreted the problem wrong or anything? I think we did this right, so Mike, sorry about that. I think that might just be an error in the book, because I think this is done correctly. No, if you subtract from 100, you get 93.
Right. But that's what the answer is in that 9%.
Does anybody, you guys don't have, did anybody buy like a solutions manual or anything? I should have brought mine in here. It looks like this is done correctly. Yeah. Thanks for checking. That doesn't happen real often, but there are a few of those. Good questions? What's next? So far we've all been on chapter 3, which makes sense. That's what you've been working on. That's fine. Yeah, Austin. Chapter 3? Okay. Yeah, that's the one that Taisha had asked me a little bit about. First of all, I don't know, you might have missed this, but whenever they refer to the standard normal distribution, they mean the simplest possible normal distribution you can think of, where the mean is 0 and the standard deviation is 1. And the nice thing, what's cool about that is 0 in the center, and then each notch is exactly 1. It's as simple as you can get. That's called the standard normal. So in 29, when they said that you were supposed to use the standard normal, do you notice right away I wrote up here? Okay. Then, oh yeah, deciles. So we had to look up in the table, where do you find 10% below? So in the table, try to find as close as you can to 10%. And this is what I came up with. You want to just check it, see. So let's try to find a readout of 0.1000. As close as you can get. And I believe it's negative 1.28, isn't it? Yeah. So there's your 10% decile. And for this decile, I cheated. And I don't mean that as a bad thing. Remember, these nice normal distributions are symmetrical. And if 10% is negative 1.28 standard deviations to the left, shouldn't 90% be symmetrical 1.28 standard deviations to the right? Yeah. And by the way, you can check it out. Go in your table and look up 90%. And you'll see, you'll get it, positive 1.28. So that was 29A. 29B, I started, Austin. They said, what are they? What are the deciles in this case? When this is the mean and this is the standard deviation? So all I did is take these two, I took the first of these numbers, the negative 1.28, and I plugged it into our good old Z formula. The only thing missing this time is X.
That's a good part.
Mm-hmm. Which score in this situation, which score lands on the 10% decile? And notice the score is the only thing we don't know, the X. And so you got to do a little algebra. I found out it was 60.5. So that means anybody below 60.5 inches in this particular problem is in the bottom decile, the bottom 10%, the smallest 10%. Now, I didn't do part 2, but part 2, I would do this over again, and this time I'd put a plus 1.28 here. Yeah. Yes, Heidi. 311C. Oh, part C is where you have to do it all over again, isn't it? I think this is the one. I gotta make sure. Yeah, this is the one about the locomotive. Yeah, and then when you got to C, it said do it all over again with a different mean and different standard deviation. Isn't that what they did? So let's see. Do I have the right stuff here? So yeah, the new mean you're supposed to use is 0.41. The standard deviation is 0.02. So this is the correct one. Okay, so what proportion are higher than 40%? Or excuse me, are higher than 0.40? So I take 0.40, I subtract my new mean, I divide by my new standard deviation, and I come up with a z-score of negative 0.5. And when I look it up on the table, I got to subtract from 100 because it wants above. Okay, so let's look it up. Negative 0.5, negative 0.5, 0.3085. Yeah. But the book wanted above, so I had to subtract 0.3085 from 1.00, and that's where I got the 69.15%. I didn't quite show that.
What about the second part? Do you have
Yeah, the
part-
second part of C, find the proportion of adhesions between .40 and .50. So now you got to do both scores, .40 and .50. Get them both, subtract. So, when I did this one, well, we already knew this. We just got that up here. When I did the .50 score, I got, holy cow. Okay, now, here's another good lesson. What happens when you get a z-score of 4.5 and you go to your table? We're like off the chart. Doesn't it only go up to like 3.8 or something? Yeah, anything, if I haven't said this already, if you get any z-score above 3.8, you can just regard that as 100%. And if you get anything below negative 3.8, you can just automatically regard that as 0. Okay, so this I'm just calling 100%. Okay, so subtract, and this is kind of ironic. Look what the answer is. And it just by accident is the same answer as 11C part A. I hate their coding on this. This is part C where you have to do part A and B over again. So this is like 11CA and 11CB. It's a little bit too thick for me there, but hopefully that makes sense. So like when you got to part C, they said do the whole thing over again. Is what it amounted to. Only this time use a couple different numbers. So does a different mean and different standard deviation make a difference? Yeah, it's a whole new problem. So if they could, for example, improve the adhesion of their locomotives by doing some new kind of part that somehow stuck to the track better, and that would change the mean and the standard deviation, does that make a big difference? Yeah, quite a bit. So sometimes the hidden heroes are the researchers behind the scenes that are trying to discover new ways to improve products. And sometimes we don't hear about it until they come out with their marketing name or whatever, but you know. I got to tell you a really cool one. One of my hobbies is to study how science is copying God's designs. They're doing it daily. It's a huge part of science now. And one of the really cool ones is the gecko. You guys all know how they can walk up walls and walk on ceilings, and they have no problem sticking. Well, they got a brand new glue coming out now that's based on the gecko. And it's just hitting the market. I can't remember what they're calling it. It's actually a mimic of that and the mussel. The mussel is like a shell that sticks onto the hulls of ships underwater. It's like it has no problem with water. You know how most glues get diluted? Not the mussel. In fact, they have to use chisels just about to knock them off boats. Otherwise, it's not good for the boats. So periodically, they have to take the boats, dry dock them, and then somebody has to sit there and knock all these mussels off. So anyway, it's a combination of mussel glue and gecko glue. Maybe they'll call it mecho glue or gussel. I don't know. Anyway, I doubt it. They usually like to come up with something more clever, like El Sticko or something like that. That wasn't clever. Or how about I'm stuck on you, or I don't know, whatever. What else would you like to go through? All chapter 3 so far. That's okay with me. Just don't forget about those other two guys. Yep.
Can you go through one about how you find the standard deviation?
Yeah. So that's a chapter 2 question. Okay, good. Well, here's one I made up. I just I gotta think here. Can't quite see it all, can you? Let me bring this over. Yeah. Okay, so here's what I made up. I just put these numbers along the left. And remember how the one I made up in class the first time, I had it come out really nice? Yeah. This one, I just made up on the spot so it doesn't come out so nice. The mean is not a nice round number. So, here's my numbers. The first step is find the mean. So I added these up. I got 940. And then I had to divide by 8 because there were 8 of them. Got 11.75. I rounded it to 11.8. I don't know if I should have, but I made it a little easier. Then I had to subtract 11.8 from each one of these. Gave me these 8 results. Next, take all these answers and square them. Add all these wonderful guys up. 239.52. I had to divide by n minus 1, so there were 8. I had to divide by 7. Came up with 34.22. And then I took the square root of that. Of course, I did a bunch of rounding on the way, but my final standard deviation came out to approximately 5.85. And a reminder, I mean, there's a good chance I'll ask you to do a short standard deviation where you have to show me the steps like this. It wouldn't be any longer than this. And here's a case where a calculator would be an assist to you when you do the adding. I know some of you have stats functions on your calculators. I'm not. Go ahead and hit the mean button if you want and do stuff like that. But still want you to show me how to do it. Okay? I want you to really know how to do it. If you want to use a calculator to help you add the columns, that's okay. Yes, your question? You mean this column?
Yeah.
You take whatever the mean is and subtract it from each one of these numbers.
Yeah, but you don't have to add up that column for the.
No, there's no adding in that one. The very next step is to take each of those and to square them. So yeah, you're right. There's no adding of that column. Correct. That's pretty sloppy up there, but there's another example of a standard deviation. Looking at this kind of sloppy page, can you tell me what the variance is? Now, that's kind of a little bit of a trick, but all I'm asking is, isn't the variance just everything up to the last step? So right before you take the square root, that's the variance. So the variance is 34.22. I didn't make a lot of the variance, but it's just kind of right before you take the square root to do your final step. Anything else we can do to better get you ready? Maybe I should just take a moment and talk about, you've never had one of my, some of you have, but maybe you haven't had one of my tests before. And my style is, I know some, especially other professors might argue with me on this, but what I do is I give you as much time basically as you want, as long as you do it in one sitting. So in other words, you at least don't have to sit there and watch the clock. The idea being, I always hated that when I was fighting a test, and at the same time I kept going, look at that confounded clock up there. I remember wanting to take a shotgun and blow that thing off the wall on occasion. You don't have to do that because first of all, this clock is not dangerous. No, you don't have to do that because if you want to keep going, I'm going to let you do it. So now, this might get a little complicated, and it's still not perfect because if you guys have a 9 o'clock class, you got a problem because I'm saying I'm not going to let you go away and come back later and finish it. If you want to keep working on it, I'll let you do it, but you're going to have to make a choice. You got to stay and do it. And now, what I will do is, if another class, I don't think that happens in this case. I don't think anybody else is coming in this room next to us. So we could just stay here and keep working. And I haven't had this happen yet, but I mean, if somebody wants to work on it for a month, well, now we got a problem because it could be a problem for eating and sleeping and things like that. But if you want more time, pretty much I'm letting you have it. So I'm trying to take away one of those scary things about math tests, the confounded clock. I don't know if you had one of those teachers. I did once who said, all right, put your pencils down now! And he would say it just like that. And if you didn't put your pencil down, you took off 10 points. It's just weird. But anyway, I won't do that. Just keep working. Take away a little bit of the nervousness. I know it doesn't do all of it. Okay. Now, let me also tell you that my goal is to write a test where you should have enough time to get it done in the 50 minutes. But each person is different in speed, and so this leaves you with some flexibility, okay? Some people are annoyingly fast. We all hate that person who gets done first, and you're like, I'm on question 1, and this guy's walking out and looking confident. You've all seen that and hated that, right? Yeah, or then, and then there are some people who are just on the opposite end of the scale, and I'm like, okay, you still want to work on it. Okay, I do want to go home tonight. No, I haven't had too many of those. Okay, questions. So I thought I'd just insert that so you know. And as far as the style of questions, they should look very similar to the kinds you've been doing on your homework. You shouldn't come in and go, what is this? That should not happen. If it does, well, then makes you, then, I don't know, maybe you've been in a different book than I have, or haven't been around or something, because it should be the same kind of style stuff. So the idea is no real huge surprises on test day. Yes?
Do this one, 5 numbers summary.
Yeah. Let's see. That would be chapter 1. Let's see. I suppose I'll just make something up, huh? Okay. So what I'll do is we'll insert a page here. 5 numbers summary. And so everybody remembers, what do you have to do for a 5-number summary? Basically, just got to go median happy, right? You find the first median, then you find the medians of the 2 parts that divides it into, and then you throw on the high and the low. Okay. So let's just, I don't know, we'll just make some numbers up. There, I'll just stop with that. Okay, let's find the 5-number summary. Well, one bad news thing about the median is really the first thing you have to do is sort the numbers, right? So we got to put these in order. So I'll just make a new column right next to it. And I don't know, should I do this so I know I got them taken care of? What's next? 14. Then we got a 19. 21. And then the last three are exactly the same, aren't they? Oh, thank you. Oh yeah, and then we have 42, 50, and 80. There we go. Okay, so there's our numbers. What do we, I don't even know how many we have. 1, 2, 3, 4, 5, 6, 7, 8, 9. Well, that was nice. So there's a middle one, and it's the fifth one, right? So right off the bat, there is quartile 2. We don't have to do any calculating. We also now have two separate groups, up above this and below this. And above this, we have an even number of numbers. So what does that mean? Of those four, we have to take what? The midpoint of those two central numbers. So that would be what? 21 divided by 2, which would be 10.5. So quartile 1, I should just write this down too. Yeah, shouldn't put a colon in that thing. Never. Okay, and this group down here, there's 4 again. What's the midpoint of those two? 42 and 50, there's a distance of 8, so that would be 46, wouldn't it? And then, just throw on the high, and the low, and we have a 5-number sum. So actually, this was kind of lucky that this turned out. It's kind of a mixture of odd and even, which is kind of neat that it worked out that way. Because then you got to see a little bit of both. Yes? What do you mean like make a histogram? Probably, they take long by hand, so I probably wouldn't have maybe one, and maybe not. No computers. There's no computers on this test. When you do the chapters 4 through, so how do you make a histogram? You would, by hand, you would do the thing where you, remember you have to make a frequency table first? And then you would sit, and then you got to make a decision. Oh boy, I got to divide this up so I get somewhere between 5 and 10 bars, and you got to pick out your interval. Yeah, you have to. But I tried to pick something that wasn't obnoxiously long for you. You know, you just reminded me of another thing. After you did this, I might have you make a box plot. That should be pretty easy after this, right? What do? You make a box that goes from here to here, Q1 to Q3. And then there's going to be a bar at Q2, and there's going to be whiskers up to Q0 and Q. So once you got this done, a box plot, I guess you could call that a graph, but it's not very hard after you've done this groundwork. Yes? Frequency table is just, okay, here's what you, it's not real easy to make this up, but I would have a list of numbers. And the first thing you would do is look for the high and the low. And let's just say there were, I don't know, a distance of 70 from the highest to lowest number. Now your next thought is, boy, I would like to get between 5 and 10 bars here. So let's say it's 70. What number divides, from 5 to 10, what number divides nicely into 70? Well, a whole bunch of them. 5 does. Why don't we just say 10 goes into 70 7 times? Cool. I'll make my intervals 7 big. Now you make up your intervals, and then you just go through them one by one, and using a little, you know, which category is this in? This one, and that's your frequency table, and then you can easily make that into a histogram. Is that enough for you? Yeah. Yeah, see, I'm glad you're asking about that, because we haven't done stuff like that for, what, 3 weeks? Since way in the beginning of the semester we did that. So it's been a while. Yeah, you got a question? No? Well, I'll tell you what we'll do. Since some of you may be happy with where you are, I'll just let you go. And if you'd like to stay, we're going to keep reviewing. Okay, so if you'd like to leave, you're welcome to. We'll just keep, I'm going to just see, some people might want to hang on and ask some more questions. So we got like 8 minutes to go. Don't forget then, we do have a test, no computer part to it, and it's on Wednesday.
Oh, maybe we talked about this already.
3.7?
Yeah, when you're talking about like the percentages that are always the same,
Oh yeah, the 95, the 68, 95, 99.7 rule.
yeah, and then when they ask like the percentage, to use that to find like a little bit of a percentage, yeah, sometimes I don't.
Okay. See, that only works when you're right on a notch. So like if you had a z-score of 2, well that's right on the 95% rule. Okay, so you say 7 is a problem like that?
Yeah, where it says, how short are the shortest 2.5% of all pregnancies?
Okay.
How do you know that that's the 2.5%?
Yeah.
Like where does it end?
Can you tell me? Okay, what number is? Okay, those of you in here, if you could quiet down, I'm still recording this. What was that again? What number?
It says 3.7.
And did they give you any information in that problem? Yeah, they said the mean is, oh, it's on the previous page. The mean is 170. I hate that. That continues from the previous page.
When I saw the answer, it says less than 234 days.
No, 3.7 says the normal mean is 263. And standard deviation is 16. No, he was right or wrong.
Oh, I'm looking at example 3.7. I know what the problem is now. Exercise. That's another gymnastics thing we have to do in here. Okay, let me come back and we'll start that over again. Sorry about that. Okay, now the mean is 266 and 16. Okay. And now the question is, in part B, what percent of young women? No. How short are the shortest 2.5%? Okay. Now, using the 68, 95, 99.7 rule, stop at 95. That's 2 notches up, right? If 95% are squished between these two, what does that leave for our two sides?
5%.
Correct. Well, how many are only on one side? Half of 5% is? Yeah. So do you see that they really asked you a question about something being right on the notch? Okay. So, in effect, are they not telling you, oh, it's right on the second notch? Okay. So they've actually told you the z-score. It's -2. And so if I know that, look what I know. First of all, let me just write that down. Maybe, do you want me to go? I can tell the way you're looking at me. I should go over that one more time. Okay. If you go 1 standard deviation either way, that'll be 68% of the data. If you go 2 either way, that will always be 95% of the data, and 3 is 99.7.
That's what I was thinking, that 2.7%. You know what I mean? Like that's the next notch.
Divided in half, yeah. But the thing is, half of, no, it's not, it's not 2.7, it's 0.3% is remaining. And on each side, that would be 0.15%. real tiny amounts past due.
Yeah.
So what are you
So-
wondering about?
Well, because,
Why is it not 100?
no. Like, okay, it's 95% for here for the first notch. Well,
No, 68.
I
95
mean,
is
yeah,
2.
and then there's two. Then like on the grid for the number of days, then the third notch would be 99.7, right? So like the third line is 99.7 apart, right?
No, here, let me pull a graph out. I think I'm seeing, yeah, that's okay. I think I'm seeing a little bit better what's going on here. I want to pull one of these out. Okay. All right. Percentage-wise, the blue is 68%, and between here and here, that's 95%. The numbers, though, you seem to be mixing it up. This is the mean, 266. This is 16 greater. That's what this is for. 282, and 298. And we could go another one if we want. Okay, that would be what, 314.
So between not those first two, not the second two, but that one you just made there, and
Yeah.
the one on the other side, that's 99.7, right?
Correct.
So then if you go to the other side, that would be 234, right?
Could be. I gotta figure it out.
And
This
it's
is 250.
99.7.
This would be 234. And this would be what, 218?
Oh, the second one is 234?
Well, you gotta subtract 16
okay.
each time, if I did it right. 16, 16 lower, 16 lower.
So then, what are the two, 'cause then it's 95%
From 234 to 298 is 95%.
so then why is it 2.5% is the less than, less than 234?
You mean, why? It's not. Okay, 95, all right, 95%.
Is that what you're looking for?
Well, maybe I should just, let me finish the problem, okay? I thought I would clear things up, but maybe we should just look at the problem and then let's go back and see if you want to ask. Okay, now look, let me ask you this. Do you see where I got this -2 from?
Yeah.
Okay. Now, use our familiar formula and what happens? Okay, we know Z. I forgot. What are they asking us? Remind me. Just ask the question one more time. All of that. We can't remember what we were doing.
How short are the shortest?
Oh yeah.
2.5%?
So you're looking for the score. And then that's 266, and this is 16. Okay. So you need to solve for x. So you would multiply both sides by 16. Yeah. Let me get rid of this. Okay, so we multiply both sides by 16, and we get this. Now we add 266 to both sides. Okay, and now we know what I can't remember what that number stands for, but now we know the point that 2.5% is wrong.
When I was looking just solely at the percent though,
Yes.
it seems like that doesn't make sense, but I
Okay.
did the percentages and I didn't do the looking for X thing. Because of when it said it would be the percentages.
It's kind of silly. I could have looked right here and seen the answer too, because what
Yeah,
it's saying
how
is,
did
what's
you-
2 notches left? 1, 2. Oh yeah, 234. See, that doesn't normally work, because usually it's -2.62.
Yeah. Where is the 2.5% from then? Like on the graph, where is it?
I know it says 2.15. That's because I simplified it just 68, 95, 99.7.
So I think that's the part I didn't understand, was that because it's supposed to be like 95%?
Yeah, 95 is in between, so that leaves 5 for the two sides. Okay, well then how many are just on one side? Half of 5 is 2.5. That's where the 2.5.
Okay. Okay.
So, what you really gotta do is get really familiar with the 68, 95, 99.7 rule. Because here's an example how we're using it kind of in reverse.
Yeah.
Yeah.
Okay, thank you.
You're welcome. Welcome back. Thanks for writing.
If you had my assignment for homework, the chapter 2,
Uh-huh.